morning students. This is 8085 instruction set. So this is the last category. The name is control instructions or machine control instructions. So these type of instructions control machine functions. What is this type of instruction? Control machine functions. What are the machine functions? Such as halt, interrupt, or do nothing. So these are the some machine control functions to control these type of instructions. And also it includes push, pop, input, output instructions. These instructions are already I explained. Data transfer, that is push into the stack, pop into the stack, exchange top up stack with HL register pair, copy HL in stack pointer, read from input port, so write from output port. So these instructions are already explained. Now I just explain only alt, interrupt, and no operations. So first we shall discuss NOP. Here all the instructions, the operand data are none, only the opcode is presented. So the first instruction NOP, that is no operation. So no operation means, the meaning is no operation is performed by CPU. No operation is performed by CPU. That is the CPU is kept busy but doing nothing, used in time delay routines. So no operation is performed by CPU. Whether it indicates that is a no operation can be indicates the CPU could not work because it's kept busy but doing nothing. So these are all the meaning for NOP. Next, next one HLT or halt. So halt and enter wait state. The meaning is halt and enter wait states. The significance, the end of program. So all the ALP, that is assembly language program, we have to write the end of the line HLT. HLT means it indicates end of program. What is it? Indicate the end of program. That also called the CPU finishes executing the current instruction and halts any further execution. That is the meaning. CPU finishes executing the current instructions. Okay, next DI. So DI means it is disable interrupt. Disable interrupt. Here the operands are none. So these interrupt enable, that is DI enable. Flip flop is reset and all the interrupt except the trap are disabled. What is RST 6.5? Sorry, RST 5.5, 6.5, 7.5. So these all are interrupt are enabled. The flip flop is reset. The only interrupt, that is trap, is disabled. So that is the meaning. Here no flags are affected. What is the flags are not affected in disable interrupts. Okay. So 7.5, 6.5, 5.5 RST, that is restart interrupt. 7.5, 6.5, 5.5 are these three interrupts are enabled. Only interrupts trap are disabled. Okay. No flags are affected for DI. The next EI, that is enable interrupt. These instructions enable all interrupts. What is these instruction enables all interrupts. Before in DI it enables only 3 interrupts except trap, but here all the interrupts are enabled. Okay, that is a different. Here also no flags are affected, and DA and EAR, the flags are not affected. Okay, go to next. Okay, next RIM, RAM. So the RIM meaning is read interrupt mask. Read interrupt mask. So this is the multi-purpose instruction. What is this? Is a multi-purpose instruction. So how to read the interrupt pins and what are the status. Here there is one figure is there, that is D0 to D7, which is 8 bits. So D0, D1, D2, D3, D4, D5, D6, D7, these are all the 8 bits. So D0 presented in 5.5, that is RST 5.5, D1 6.5, D2 is 7.5. These three D0, D1, D2 are interrupt masked, that is bit equal to 1. So these bits are called maskable interrupts. Okay. The next IE for D3, that is interrupt enable. IE is interrupt enable. Whenever the interrupt is enabled, the flip flop is set, that is if bit equal to 1. Okay. The next D4, D5, D6. These three bits are called interrupt pending, that is if bit equal to 1. That is D4, D5, D6 are 1. And that time the interrupts is pending, the signal is pending, that is bit equal to 1. Then last one D7 is serial input data bit. What is serial input? That is SI, serial in data, SID. Okay. The next is similar to SIM, set interrupt mask. So this is also multi-purpose instruction used to mask interrupts and serial out data. Before in serial in data, it is masked to serial in data. Here in set interrupt mask, it is used to mask interrupts and serial out data. These instructions, it interprets the accumulator, only the content of accumulator. Okay. So now I am taking D0 to D7 for 8 bits. So D0 is M 5.5. M means it is a maskable interrupts. 6.5 for D1, D2 for 7.5. These three 5.5, 6.5, 7.5 are the mask interrupts. These three bits are called set, that is bits equal to 1. Likewise MSE. So mask set enable if, that is MSE means mask set enable. That is D3 bit goes to 1, it set enable, mask set is enable. The next reset 7.5. If D4 equal to 1, it indicates the interrupt pin, that is reset RST 7.5. Then XXX for don't care condition, and the STE for serial data enable, SOD for serial out data. There are two conditions are there in serial data enable. Whenever the serial D6 is 0, it is disabled for SDE, or it is 1 for serial data is enabled. Okay. So this is the 8085 instruction sets, totally 5 instruction sets. One is data transfer, second one arithmetic, third one logical, fourth one branch instruction, then last one machine control instructions. So this is 10 more question. So I have explained all the instructions and as well as the examples also. Okay, keep watching video. Any doubt, please contact me. Okay, thank you.